Hello fellow AGD coders, welcome to another video. Trying out a new microphone driver. I hope that this one is a little bit clearer. I apologize if previous videos have been a little quiet. Anyway, let's get cracking. Today we're going to be looking at using Sprite ink together with a couple of pokes in order to allow us to color sprites in more than one color. So let's begin by looking at a sprite here. There you go. This is from Andy John's game that I've been using as a tech demo for the last few videos, and as you can see here, I've also created a block in blue, which is basically I've created a little border here, and this is just a test environment, really, not a game. And I've created a little border so I can put the sprite in the middle, and we can take a look at how the coloring effect can work. So here we've got our little sprite, obviously inside the sort of walled cell, so to speak. But anyway, the standard way to color this, of course, as most of you know, is just to use the sprite ink command or sprink command in AGDX. So let's just give him a color like so, and we'll just run it just so you can see what happens. There you go, that's cyan, and no problems with the rest of the area. The reason for that obviously is that the sprite is exactly 4 characters in size, and there's no overlap, so there's no attribute clash at all. Okay, so now let's take a look a little bit closer. We'll look at it here in ZX Paintbrush just to give you an idea about what the possible options would be to color this sprite. So as you can see, it takes up 4 squares, as I said, and this sprite is designed, if I just let me just zoom in a little bit more. There we go. Okay, so this sprite is, as you can see, it takes up 4 characters like most AGD sprites do, and it's designed so that his helmet here is actually going to be on one row, and the rest of his body is going to be on another. So because he's moving horizontally, then technically speaking we could color the top and the bottom half differently, and it wouldn't cause a problem. But of course within AGD we can only color in units of 16 by 16. Obviously sprite ink covers the whole sprite. So what we could try, of course, and this is a method that I know Gabriele Amore uses. Hi Gabriele, if you're watching. You can add 8 to the X coordinate here, and then use a different ink, and then subtract X again, and this basically drops the sprite down 1 space. But as you can see, this does cause a problem because we're still coloring in 16 by 16 squares, and it's creating an attribute clash here. This is the reason we built this border around the sprite, because we want to check if we've got any attribute clash, and obviously that is something that we want to avoid. So the question is then, how do we address this situation? And the answer basically is that we use a poke, and what we're going to do is basically poke AGD so that rather than drawing 16 by 16, in this case it's going to only draw the top row rather than 2 rows. So basically let's look at how we do that. Obviously here I'm in Spectaculator, but most emulators have the option to add a poke, and the poke that we're going to use, we'll just put it in here now. Poke the memory, and the address that we want, it's 32866, and we poke it with a 2. So normally this value is a 3 because it checks for straddling sprites, which you may have heard about in the previous video. And as you can see there, we have the effect that we want. And if I remove the first example here, you'll see that yes, indeed, only the first row of the sprite is being colored. So that would seem to certainly solve the problem, but of course by poking the memory like that, we're effectively changing spriting for the whole of AGD. So every single sprite we color now is going to have to be changed, and that really isn't something we would want necessarily to do, because obviously a lot of the sprites, including the player sprite, might be colored slightly differently. Not only that, but if we go into the sprite editor here now, you'll see that this poke has had an additional and rather unwanted effect, which is that the sprite editor no longer allows you to edit the bottom half of the sprite. So this is a good example of where you might implement something which seems pretty straightforward, but then it affects another part of the code. This is why you have to be very, very careful when you're poking certain things. So we'll have to find a solution to this, and the solution basically is that we need to poke the value within the script and then poke it back again, so that it only works within the script. And I have done a video on peeking and poking in AGD, and I know that Luca Bordoni has done a piece on it on his website. And if you do a Google search for peek and poke in AGD, you should be able to find that piece if you're more interested. So the first thing I'm going to do then, of course, is let's poke it back to its original value. So 32866 here, and we'll put it back to 3. So let's get it back to normal, and let's just have a look. There we go, we've got our sprite editor back. That's nice. And there you can see the full color once again here. Okay, so poking in AGD is relatively straightforward. The first thing we need to do is to load the accumulator with the value that we want to poke, and that's done using value 62. So the first thing we do then is we type here ASM62, and the number that we want is the number 2. So that gets us ready for the poke, for the value that we want to poke. The second thing we have to do then is move the value of the accumulator into the address that we want. In this case, we need to use ASM 50, and 50 basically transfers the accumulator to the address that you define. And then so the last thing we have to do is basically tell AGD the address that we want to send it to. Obviously we have to do this with 2 numbers rather than 1 long number, so I'm going to use the DEChex program here. It's this little app that David Sapphire wrote. We put 32866 into here, and it tells me the numbers that I need to use, and those numbers are 98 and 128. I'll make this program available for download, and again, thanks David for writing it. And we then put Spring 5, and then obviously at the end of the code we do exactly the same thing again. In this case we're going to put the value 3, and it's the same memory address there. So basically all we've got is at the top we've got poke 328662, and at the bottom we've got poke 328663. So this will only work, I'll just move this out of the way, this will only work within the code itself, within that particular sprite event. And as you can see, no problem with the sprite editor. And if I was to use other sprites, for example the sprite number 1 or anything else, it won't affect any other sprites. And it doesn't take up a huge amount of memory either. It only takes up 3 or 4 bytes per command. So basically it's very low impact memory wise. So there you go. As you can see, it's now fully working, and that essentially is how we can color a sprite in 2 horizontal bars. We basically just poke AGD, set the colors, move the X coordinate, and poke it back, and that will work fine for a sprite that's moving along a horizontal plane. So that's one part of it done. Obviously not all sprites move along the horizontal plane. It certainly wouldn't be a very exciting game if that were the case. So let's think about vertical movement here. In this case, Andy has created a kind of portcullis or gate, and this gate is going to be moving up and down. And what that means is that the left and the right side of the sprite could potentially be a different color, and that also won't cause any attribute clash. So Let me create a second border here to test it out, and we'll put the sprite in there. So let's create a new one, and this time we'll use type 1. So we'll obviously change the image as well. There we go. Let's change the type, and yeah, there you go. So we'll put sprite code in here, and we'll put the sprite ink color here as 6, and as you can see, that will just color it as you would expect. Now obviously what we want to do here is color the right side of the sprite differently to the left, so we'll have to use a different poke here. So first of all, we'll just put the poke in, and then I'll show you how that actually works. So let's poke the memory directly first of all, just to show you the effect that this will have. In this case we're using a different address obviously, and in this case the address that we're going to use is 32882, and we poke it with a 0, and this is going to stop the ink being painted on the right hand side. And as you can see there, that's worked perfectly on the gate, but it's also had an impact on the night. As you can see, the night is also half colored as well. So obviously we want to avoid this, and again the solution is to put the poke into the script address. As you can see, this poke doesn't actually impact the sprite editor, which is a good thing, but obviously it does have an impact on any other sprites which are not vertically moving. So same problem really. So let's poke it back again, and the value in this case that we need to poke back is 119, which is basically loading a value into the screen. So we'll cancel that, or rather we'll re-enable it. So there it is, back to normal, and we'll go into the events editor here, and we'll add the poke that we need. So it's exactly the same principle as we did for the horizontal one, and we'll put the ASM command in here to poke the value to 0. So we'll start with ASM62, that's load the accumulator with the value 0, and then we use, as before, ASM50, which will tell AGD to poke the value into the address that then follows. So we'll bring the deck hex code back in. Incidentally, Luca has a little routine online that you can use as well, which will also do the job. And there you can see the two numbers that we need to get that value. This is basically dividing by 256. It's splitting the number into two values, into two 8-bit values. Converts a 16-bit number into two 8-bit numbers. And we'll do the same thing, and obviously now we're going to poke it back to 119. So we're disabling and then re-enabling that particular command, which is painting the screen at that point. And that will basically stop our sprite from being painted. So let's straight away put the additional code in here to add the second color. Obviously this time we're dealing with the Y coordinate, so we're going to add 8 to Y, add another sprite ink, and then subtract 8 to Y. So obviously the add and the subtract should always be equal so that the sprite doesn't move around. And as you can see, there we go, we've now got a very nice sort of rhubarb and custard effect, if you remember those sweets, on that gate. So obviously this is just for a demo. I'm not going to use such garish colors, but it does show you what's possible. So we've got there now the night being colored in 2 bars horizontally, and the gate is being colored in 2 bars vertically. Now of course the option then would be possibly to combine the two, and this would restrict the movement of the sprite to 8 pixel movement, because we wouldn't be able to avoid attribute clash otherwise. But this is something that Gabriele uses in his games quite a lot, and his games are very colorful. The trade-off of course is that the sprites are not as smooth, because obviously they're moving in larger sort of gaps, but it is quite a nice effect if you especially want to avoid attribute clash and have some colorful games. So I'll just show you very quickly here how we can combine both of the effects that we've already seen onto a single sprite. So I've created a sort of diamond here, and I'm going to color each segment, each square of the diamond in a different color. So I've set this at sprite type 2, and I'll now edit the script for sprite type 2, and we will just go into here, and all I'm going to do really is just add the very same pokes as I did before, but in this case I'm going to do both of them. So we'll start with the initial one that we already looked at previously here, and so we'll type this in. Obviously there's a fair few numbers now. We're going to have something like 20 numbers in total, but it doesn't take up a lot of memory. Each one of these is a direct machine code command, so in actual fact it takes up very little memory, just 1 byte per command really. So we'll add the first one to enable and disable the vertical, and we'll do the same for the horizontal as well, and obviously restore them at the start and at the end of the sprite ink control. Okay, so we'll put that in here, and we'll add the second command as well. The other thing to bear in mind, of course, is if you want the sprite not to affect the background, you can still use something like sprite ink 7 at the very start of the code before you run the ASM, and that will restore the whole sprite back to white. But as we'll see later in the video, we could also use the attribute buffer, which I've shown you in a previous video, and that obviously is a little bit more flexible than the standard sprite ink 7. But you could put sprite ink 7 at the top of the code, and it would have the same effect. So all we're doing here is just changing the parameters of the sprite ink command for a specific sprite. Okay, so let's just test it. I'll put a command in here to change one color, and yep, indeed we have managed to color only one corner of the sprite. So that's exactly what we wanted to do. All we need to do now then is add the commands which will move the position across 8 pixels and down 8 pixels and around. And again, be careful here that your addition and subtraction all finish up with 0, so that the sprite hasn't moved within this part of the script. You can still move the sprite around in other parts of the script according to key presses and things like this. But obviously with a sprite like this, if you want to avoid color clash, you would need to move the sprite in increments of 8 pixels. Okay, so let's take a look. With a little bit of luck, we should find that we've now added 4 colors to our sprite. So let's step back and run it and see, and yep, there you go. So perfect, all fine, 4 colors, and you can use this to if you've got a static sprite, like for example maybe a flag that's waving or something like that, or maybe a door which opens, whatever you like. Use your imagination. Obviously you can use it to create a sprite that's not moving, that is perhaps animated, and that would work perfectly well in 4 colors and would probably look quite nice. Maybe a fire burning or something like this. Okay, great. So that's the basic principles. Pretty straightforward, as you can see, just a few little pokes. And obviously what we can do is combine this with the attribute buffer, and I'll show you a couple of examples of that here. So as you can see, we've got the knight moving here left and right, and he's not affecting the background at all. When he's passing over the steps here, you can see the colors are being restored, and the character sprite here is not being affected, and you can see it here perhaps even better with the green grass and the pillar, and he's passing underneath that sort of scroll and he's not affecting it as well. So basically, yeah, proper 2-color sprite there, moving smoothly without any problems. And the vertical sprite, the portcullis gate, I can also show you an example of that running as well. Here you go, and as you can see, the sprite can pass underneath and it won't cause color clash too much. So most of the color clash is avoided here, which is nice. Okay, well, that's the end of the video. I hope you found it useful. Thanks again for watching, and as always, happy coding. Goodbye.